Good morning and welcome back to 8.1, Comparing and Interpreting Rates. Let's begin. So the first and really only definition you need to know for this stuff is a unit rate. And what a unit rate means is a rate at which the numerical value of the second term is 1. For example, if someone can type 240 words in 8 minutes, we express that as a unit rate of 30 words per minute. Okay? So what's going to happen in today's lesson is you're going to get rates and units in different forms and different amounts, and you're going to want to convert them to the unit rates in order to tell which one has the better value, for example. So we will move on to the example here in just one moment, once you've had a chance to copy that down. Okay, let's take a look at an example here. Example 1, comparing two rates expressed in different units. So it says Natasha can buy a 12-kilogram turkey from her local butcher for $42.89. The local supermarket has turkeys advertised in its weekly flyer for $1.49 a pound. There are about 2.2 pounds in 1 kilogram. Which store has the lower price? So the issue right now is that we have one expressed in pounds and one expressed in kilograms, and that doesn't allow us to determine which one is the better value. Okay? What we're going to do is we have to make them the same. Okay, so I'm going to find out, my goal is to find the price per 1 kilogram. Okay, so if we pay $42, so this is the butcher. If we pay $42.89 for 12 kilograms, we want to figure out what do we pay for 1 kilogram. Okay? So to solve this, just like you would have, throughout your high school time, you just cross multiply and divide. 42.89 times 1 is 42.89. 12 times x is 12x. I won't show these steps every time, but I will for the first one. Divide both sides by 12. X equals 3.574. So what this is the price per 1 kilogram. Okay? At the butcher shop. Now we know what the butcher shop charges per 1 kilogram. So now we move over to the store or the supermarket. Now the supermarket is advertising it in pounds. The supermarket says we sell it for $1.49 for 1 pound. Okay? I guess I don't really need the units there. Now let's put them for the first one. $1.49 per 1 pound. And we know that there are 2.2 pounds per 1 kilogram. So if we run this conversion quickly, let's multiply pounds will now cancel out. Oh, sorry, not cross multiply. We just multiply here. Let's get that out of there. Okay, those will cancel out. Because I don't have an x value I'm solving for, I'm not cross multiplying, I'm just multiplying. 149 times 2.2 is $3.278 is now the price per kilogram. Okay, so again, we had the price in pounds for 1 kilogram, or sorry, for 1 pound, and we then use that to find the price per kilogram. And now we can see the two prices per 1 kilogram, and we can see that the supermarket has the lower price. Supermarket charges basically $3.28 for 1 kilogram, where the butcher shop would charge $3.57 per kilogram. And that would be our answer. Okay? Let's try another one. It says Mario's on a road trip. And he wants to check the fuel efficiency of his car. Okay? In the first leg of the trip, he drove 645 kilometers and drove 645 kilometers and used 48 liters of gasoline. In the second leg of his trip, he drove 392 kilometers and used 32.1 liters of gasoline. During which leg of the trip, not trop, trip, was his fuel efficiency the best? Okay. So let's do leg 1 of the trip here, do leg 2 of the trip over here. We want to find how much gas did he use. The goal, again, is to get to the unit rate of the gas used per 1 kilometer. If we can find the gas used per 1 kilometer for both trips, both parts of the trip, then we can tell where his fuel efficiency was better. So he used 48 liters for 645 kilometers. We want to find out how much gas did he use for 1 kilometer. Okay. I'll add the units there so you can see a little bit better. So we're solving for x. Cross multiply. 48 times 1 is 48. 645 times x is 645x. Divide both sides by 645. X equals 0.0744. So this represents the gas he used. This is the liters of gas he used per 1 kilometer. Okay? Again, which is what we were looking for up here. Now we do it for leg 2. In leg 2, he used 32.1 liters of gas to travel 392 kilometers. Okay? How much gas did he use? 1 kilometer. Okay? Same steps, right? Cross multiply and divide. 32.1 times 1 is 32.1. 392 times x is 392x. Divide both sides by 392. Use 0.0818 liters per 1 kilometer. Okay. Now we can examine these two numbers, 0.074 and 0.08. We can tell that leg 1 was when his fuel use was the most efficient, right? Because it has the lower value. One more. Orange juice is sold in 1.5 liter cartons and 250 milliliter boxes. A 1.5 liter carton sells for $3.75, and 10 250 milliliter boxes sell for $7.39. Which size costs less per milliliter? So this is what we're looking for. Which size costs less? So we'll set this up as the carton, one side, and the boxes over here. They want it per 1 milliliter, okay? So the carton is $3.75 for 1.5 liters. Now 1.5 liters is 1,500 milliliters, right? Because there's 1,000 milliliters in a liter. So he's paying $3.75 for 1,500 milliliters. We want to figure out what does he pay for 1 milliliter. Okay. Now, when we calculate this, right, with our cross multiplication and divide, we get 375 equals 1,500x. And when you divide both sides by 1,500, you're going to get, depending on your calculator, I'm getting 2.5 times 10 to the negative 3, right? So sometimes your calculator will put things into scientific notation if the numbers are too big. The numbers are too big or too small to fit on the calculator's display screen. So you might have done some of this in science, right? I'll just do a quick scientific notation reminder, okay? It's 2.5 times 10 to the negative 3. So if we wanted to convert that to an actual decimal, it's negative, so we have to move the decimal spot 3 spots to the left. So it's right here. 1, 2, 3. This is where our new decimal is. So our value is 0.0025. 0.0025. Okay? This is the price per 1 milliliter. Okay? Highlight their stats so we can see it. Now we do the boxes. The boxes, you pay $7.39. You get 10 250 milliliter boxes. So 10 times 250 is 2,500. So you are getting 2,500 milliliters for $7.39. How much do you get? How much do you pay for 1 milliliter? Again, cross multiply and divide. You get 7.39 equals 2500x. Divide both sides by 2500. I'm getting 2.956 times 10 to the negative 3. Maybe your calculator doesn't show you that. Maybe it gives you the actual decimal. Again, if we had to convert that, we go 2956. Removing the decimal 3 spots. 1, 2, 3. So now for this one, you were paying 0.002956 per 1 milliliter. Now, if we examine the price for the 1 milliliter in the carton and the price for 1 milliliter in the boxes, we can see that the carton is the better deal. It costs less per milliliter. Okay. So if you are comfortable getting things into unit rates, then this section should be hopefully a little bit easier than some of the other stuff we've been doing. All right, your assignment is on page 219, numbers 1 to 11. Thank you. Have a good day.